Hi everyone, today I'm gonna introduce a new solver in CFD open form, which is Boolean simple form. For this solver, it can help us solve heat transfer and radiation and something like that. So first we can just go to the open form tutorials and heat transfer, Boolean simple form and hot room, and here we can see all the three important files. So at the beginning, we can just copy these files and paste it to our new file and define it as our pre-run file. So let's open it. So in the pre-run file, we can see these three files. There are zero file, a constant file, and system file. And now let's open the zero file. So in the zero file, we can see all the initial conditions: alpha, epsilon, k, naught, t, u. And now let's go to the constant file and see what's happening. So in the constant file, we can see the tree surface, gravity, and one transport properties and one turbulence properties. So this file is the one after using snappy hex mesh and surface feature extract. So but it's very easy to set a point before we do that. So now we just open the polymesh. So in the polymesh, there's a block mesh dict, and this file is used to define your computational domain. It's just like a container. If you just put a model inside it, and you can calculate everything you want in this domain. So let's now open it. Okay, so in the block mesh dict, we can see the vertices. This is how we define the computation domain, and after that there are all the initial conditions. So we can just use the initial conditions, and for the block mesh dict, we have our walls, inlet and outlet, and front and back. And these files are all what we would have after we run the snappy hex mesh. So now we go to the tree surface. So in this file, we can post any STL format model in it. So for the model, I suggest to use the Shepherd 3D, which is this one. Shepherd 3D. It's a one on your iPad if you can download that, since it supports STL file, and also it's very easy and fast to use. And of course you can use like SolidWorks to do it, to create your OR model. But sometimes take care that every surface should be closed, or you will get a problem. So let's see. So in the SolidWorks, we can create any models, any geometries. Like I can create a circle, or if you have lots of interests, you can create some other models like the plane, or just some simple models like a pipe, a very simple pipe. So now we go back to our pre-run file and go into the system and see what we need to take care. So here I have here we have two things. and this can be copied in the original file in the hot room system. But there are two files which are the snappy hex mesh dict and surface feature extra dict, and these two can be found online since all the initial conditions are set in the file, so sometimes you can just change it. So when we open it, we need to make sure that for our geometry, we have to let the system know that um, it needs to do your geometry. So you need to set the correct name. So here my name is just a pipe superfine, and set the name here, and it's below is the same. We change the names and change some you can change some initial conditions based on what you need. But most of them are the same. So now let's just close this. So we know that if we have these two files, we can successfully run it and let the OpenFOAM automatically create mesh. But the snappy hex mesh file, dict file, usually models. For some very complicated models, we still need to create and draw the mesh by ourselves. So now we just go back to the pre-run file. Oh, there's one thing. Since in the control dict, I set the delta t as just 2, and the end time is 1000. The start time is 0, so it will calculate. It will have a lot of time. It will have a very long time to calculate that. So here I can show you how to run the file. So we go back to our pre-run file and go to run the terminal. So in the terminal, here we can just run the buoyant boldness simple form, and it will run, but just very slow. So, but at least it works. So that would be very great. So since it actually can work, so I just open the after run and show you something, show you the results. Okay, so this is a terminal about the after run, OpenFOAM after run file. So now after we run that code, we can just do the power form and check the plot, check the geometry. I will be a little bit slow. Okay, great. So in the after ROM, we can see our geometry. So in this one, we can check the velocity and set it as wireframe. So here we can see one is the input, one is the output, and we can see when the velocity, like the air, goes into this computational domain, and how the velocity will distributed on the pipe. So the same as temperature and pressure and the nuts. Okay, that would be great. Okay, so that's all about the buoyant Bosnian simple form. Thank you.